This video will show you how to do some multivariable calculus. So we're going to start with the partial derivative. We want to find the derivative of, let's say, c of x equals 50 minus 7x. That would be dc dx is equal to negative 7. When writing it this way, it is easy to see that one is taking the derivative with respect to the variable x. This is useful when you have two or more independent variables. Let's consider the bike example from the last section. The cost function for the bicycle shop to buy, store, and sell the two types of bicycles in a given month is C of Q1, Q2 is equal to 4,000 plus 560 times Q1 plus 4,200 times Q2, where Q1 is the quantity of low-end bikes sold and Q2 is the quantity of high-end bikes sold. I want to find the rate of change of the cost with respect to the low-end bikes. This means that only Q1 is the variable and Q2 can be thought of as a constant. So the derivative with respect to Q1, sorry about that. The derivative of C with respect to Q1 is going to equal 560. And this is dollars per low-end bike. The symbol dc dq1 means the partial derivative of c with respect to the variable q1. Since q1 is the variable, the 4,200 q2 is a constant and its derivative is 0. That's why it doesn't show up here. Find the partial derivative of c with respect to the variable q2. So that would be the partial derivative of c with respect to q2 is equal to $4,200 per high-end bike. Since Q2 is the variable, 560 Q1 is a constant and its derivative is 0. In general, the partial derivative of z is equal to some function of xy with respect to x is the partial derivative of z with respect to x is equal to the limit as h goes to 0 of f of x plus h y minus f of x y over h. Notice x is the only thing changing. And the partial derivative of z is equal to f of x y with respect to y is the partial derivative of z with respect to y is equal to the limit as h goes to 0 of f of x y plus h minus f of x y all over h. Again, y is the only thing changing. Just like in derivatives, there are other symbols for partial derivatives. The other common ones are that the partial derivative of z with respect to x can also be written as f sub x, and the partial derivative of z with respect to y can be written as f sub y. Example 1. For f of xy is equal to x squared y squared minus 5xy cubed, find the partial derivative of f with respect to x, which can also be written as f sub x, the partial derivative of f with respect to y, which can be written as f sub y, then the partial derivative of f with respect to x evaluated at x equals 1 and y equals 4, written as f sub x 1, 4, and the partial derivative of f with respect to y when x is equal to 1 and y is equal to 4, which can be written as f of 1, 4. So the partial derivative of f with respect to x would equal 2x y squared minus 5y cubed. Notice that y is considered a constant while x has been changed. So y is treated as any other constant such as the number 2. So it just comes along. The derivative of f with respect to y would be 2x squared y minus 5x times 3y squared, or 2x squared y minus 15xy squared. Notice that x was considered a constant while y is being changed, so x is treated as any other constant, such as, again, a number 2. Now let's evaluate the partial derivative of f with respect to x when x is equal to 1 and y is equal to 4. Again, you can also write this as f sub x 1, 4. So you can have 2 times 1 times 4 squared minus 5 times 4 cubed. Evaluating that, that's negative 288. And the partial derivative of f with respect to y, again, when x is equal to 1 and y is equal to 4, can be thought of as f sub y 1, 4. That would be equal to 2 times 1 squared times 4 minus 15 times 1 times 4 squared, which is equal to negative 232. Another example, example number 2, for f of x, y is equal to e to the 3x minus y squared. Find the partial derivative of f with respect to x, partial derivative of f with respect to y, the partial derivative of f with respect to x when x is equal to 3 and y is equal to 3, and the partial derivative of f with respect to y when x is equal to 3 and y is equal to 3. So the partial derivative of f with respect to x would equal e to the 3x is 3 e to the 3x. The derivative of y squared is 0. The partial derivative of f with respect to y would be e to the 3x is 0 because it's just got x's in it, and the derivative of y squared is minus 2y. Then find the derivative of f with respect to x when x is equal to 3 and y is equal to 3 would be 3 e to the 3 times 3, or 3 e to the 9. And the partial derivative of f with respect to y when x equals 3 and y equals 3 would equal negative 2 times 3 is equal to negative 6. If you can find the first derivatives, you can also find a second derivative. So we can do the second partial derivatives. The partial derivative of f with respect to x and x is the partial derivative with respect to x of the partial derivative of f with respect to x. Also can be written as the partial derivative squared of f dx squared. The partial derivative of f with respect to y, then y, is the partial derivative with respect to y of the partial derivative of f with respect to y, and the second partial derivative of f with respect to y squared. The partial derivative of f xy is actually the partial derivative with respect to y of the partial derivative of f with respect to x. It can also be written as the second partial derivative of f with respect to y and x. The partial derivative of yx would be the partial derivative with respect to x of the partial derivative with respect to y of the second partial derivative of f with respect to x and y. So let's do an example of that. Example 3. For x squared plus x plus 9y squared minus 4, find all the partial derivatives. First, you need to find the partial derivative of f with respect to x and the partial derivative of f with respect to y. So f sub x will equal 2x plus the 9y squared is going to be 0 and the 4 is 0. So there's no plus. And the partial derivative with respect to y is going to be the x squared 0 is going to be 18y, and that's all. Now find the second partial derivatives. So f sub x, x means take the partial derivative of f with respect to x, and then take the derivative of that with respect to x again. That would be 2. The partial derivative of f y sub y would mean you're taking the partial derivative with respect to y, and then taking the derivative of that with respect to y, which is going to be 18. The partial derivative of f with respect to x, then y, means that you've taken the partial derivative with respect to x first, then take the derivative of that with respect to y. That would be 0. And the partial derivative of yx would mean that you're taking the partial derivative of with respect to y first, which is 18y, and take the derivative of that with respect to x, which is 0. Another example, in example 4, is f of xy is equal to 2x plus y all to the 5th power. We want to find all the partial derivatives. So again, first find the partial derivative of f with respect to x and with respect to y. So the partial derivative of f with respect to x, using the chain rule, is going to be 5 times 2x plus y to the 4th times the derivative of the inside, which is 2. So it's going to be 10 times 2x plus y to the 4th. The partial derivative of f with respect to y would be, again, using the chain rule, is 5 times 2x plus y to the 4th. Then the derivative of the inside with respect to y is 1. So it'd be 5 times 2x plus y to the 4th. Now find the second derivatives. So the partial derivative of f with respect to x and x, take the derivative of f sub x with respect to x itself. So again, you're going to use the chain rule. So you got 10 times 4 times 2x plus y to the 3rd times the derivative with respect to x, which is 2, which gives you 80 times 2x plus y to the 3rd. The partial derivative of y with respect to y and y, of f with respect to y and y, I should say it that way, is again using the chain rule. You're going to take the 5 times 4 times 2x plus y to the 3rd, then times the derivative of the inside, which is just 1 with respect to y. So you get 20 times 2x plus y to the 3rd. The partial derivative of f with respect to x, then y, means I've taken the partial derivative with respect to x. I'm going to take the partial derivative of that with respect to y. So it's going to be 10 times 4 times 2x plus y, then the derivative of that with respect to y, oops, to the 3rd power. Then the derivative of that with respect to y will be 1. So you get 40 times 2x plus y to the 3rd. And the partial derivative of f with respect to y, then x, means that we're taking the y one first and taking the partial derivative of that with respect to x. That'll be 5 times 4 times 2x plus y to the 3rd times the derivative of the inside with respect to x, would be 2. So you also get 40 times 2x plus y to the 3rd. Notice in both examples, the partial derivative of f with respect to x then y was equal to the partial derivative with respect to y then x. As long as the partial derivative of f with respect to x then y and the partial derivative with respect to y and x and all the other partial derivatives are continuous functions, then the partial derivative of f with respect to x and y will always equal the partial derivative with respect to y then x. The next thing is iterative integrals. This is a double integral. The partial derivative of, the integral with respect to the double integral of r over r over some rectangle r of f of x, y, dA is equal to the limit as m and m both go to infinity of the summation I equals 1 to n
the summation of j equals 1 to m of f of x of ij star, y of ij star over delta A. This is the definition, but we don't do it this way. We find integrals like we did previously. So in example 5, let f of xy equal 64 minus x squared minus y squared on the rectangle r of 1, 2, crossed with 1, 4. And we want to find the integral from 1 to 2, then the integral from 1 to 4 of 64 minus x squared minus y squared dy dx. What the integral from 1 to 2 and the integral from 1 to 4 of 64 minus x squared minus y squared dy dx means to first take the integral with respect to y. This means y is the variable and x is a constant. Then you take the integral of the results with respect to x. So we have the integral from 1 to 2 of the integral from 1 to 4 of 64 minus x squared minus y squared dy dx equals the integral from 1 to 2, because we haven't done that yet. The integral of 64 with respect to y is 64y minus the integral of x squared with respect to y is x squared times y. The integral of y squared is 1/3 y cubed. We're going to evaluate that from 1 to 4, then dx. This is equal to the integral from 1 to 2. We now evaluate this at the 1 and 4. So you put the 64 times 4 in for y, the x squared times 4 in for y, and the minus 1/3 times 4 in for y, minus 64 times 1 minus x squared times 1 minus 1/3 times 1 cubed, and then dx. We haven't done the dx yet, so it's still there. Simplifying this gives you the integral from 1 to 2 of 171 minus 3x squared dx. Now this looks just like we've done before. Take the integral of this. This is 171x minus x cubed. And you're going to evaluate that from 1 to 2. So that's going to be 171 times 2 minus 2 cubed minus 171 times 1 minus 1 cubed. And that's equal to 164.